We're continuing today with exponential functions, and we're going to be working with exponential growth and exponential decay. This will help you with the activity that you have for your portfolio. On the sheet that I have attached for your file, you have the definitions of exponential growth and exponential decay. If something is growing exponentially, it is increasing at a constant rate over a period of time, and exponential decay will be when it's decreasing, like we saw yesterday in our graphs. An exponential growth is given by an equation. Y is equal to A times 1 plus R to the T. This is what we would put in for an exponential growth equation, where Y is going to be my total, A is going to be my initial amount, R is my rate. It is my rate of growth, and that is in decimal form. That's very important that that be in decimal form, and T is time. All right? I'm going to have you do these examples that are on the front. I'm going to give you some examples here in a minute on another sheet of paper, but I want to tell you about exponential decay. Exponential decay, Y is equal to A times 1 minus R to the T. All the values are the same. If something is growing, we have a plus sign in between the 1 and the rate. If it is decaying, we have a minus sign. So Y is still my total. A is my initial amount. R is my rate, and that will be in decimal form again. If you are not sure how to put something in decimal form, divide it by 100. If it says 17%, put in your calculator 17 divided by 100, and it will tell you 0.17. And T is my time. Okay? So they're examples that are on the sheet that you're going to complete for your classwork today, your homework today. But I do have some examples that I'm going to show you here. Here's some exponential growth and decay. Which of these exponential functions shows growth and which one shows decay? If we remember, this is my B value. To the T. Remember, if it's plus, if it's growth, so it's going to be greater than 1 if it's growth. It's 1 minus R, so it's going to be less than 1 if it's decay. My initial amount here is 100. Okay, I have 1.7. That is going to be a growth. And that is going to be a growth of 70%. Because if I put 70% in decimal form, that is 1.7, and I would have 1 plus 0.7 to the T value, or X value is what they have here. Okay, so that will be 70%. Right here, I can already see this is a plus, so this is going to be growth. And this will be 12%. 0.12 can also be 12%. This is going to be a decay. It is less than 1. It is going to be a decay. And what I can see, this is different right here. I need to find the value 1 minus whatever that interest rate would give me a 0.4. Okay? So my decay rate will be 60% because 1 minus 0.6 is going to be equal to 0.4. And I can go over that with you if you need to later on. Okay? So now let's get into two examples. A car was purchased for $20,000. It depreciates 22% per year. Okay, that means it is decreasing. What is the value of the car when it is 12 years old? First of all, I'm going to write it. Y is equal to, my initial amount is $20,000. It depreciates, so that's going to be a minus. 22% is going to be 0.22, okay, or 22 divided by 100. And it's going to be, I want to know in 12 years what it is going to be. So now you can put this into your Desmos. I do have my Desmos and I have my calculator here. You can put it into whichever one you want. You can put it in just like it's written. Remember to use your caret key for that exponent. And when I have, wow, 12 years old, it's going to be worth $101.43. Okay. How long will it take for the car to be less than $100? Just over 12 years. All right. So here is one where we have an increase. There are 5,000 fish in a pond, and it is increasing, which is going up 2.1% each year. Write an equation to determine the fish population after X years. My initial amount is 5,000. We are growing, so it's going to be a plus. Okay, 2.1%. Remember, I moved the decimal 2 places, so 2.1. If I move it 2 places, 1, 2. Okay, so it is 0.021 to the X value because it said after X years. Now it says how many will there be after 1 year. So I have 5,000, 1 plus 0.012 to the 1 for 1 year. Put that in my calculator. It is 21, isn't it? 0.021. Thank you. And raise that to the first power, and I will have 5,105 fish. So I have increased 105 fish. Down here it says, how many fish will there be in 15 years? I'm going to use the exact same equation, but instead of 1, it will be 15. And I do my calculation, and I'm going to raise that to the 15th power this time. And I have 6,829. I have I have a decimal here, but we can't have part of a fish. Okay, we can't have part of a fish. So when I did it, my calculator gave me, if you can see it here, yeah. It gave me 6,828.98. I rounded it up, or I can say about 6,830 fish. I hope this helps. Have a great day.